Imagine a vast and intricate universe contained within the human body. This universe is a marvel of biological engineering, a symphony of cells, tissues, and organs working in harmony to sustain life. We often think of the brain as the control center of this universe, the command hub that orchestrates every thought, movement, and sensation. It's a place of incredible complexity and wonder, with billions of neurons firing in a delicate dance that enables us to think, feel, and experience the world around us. But even in this fortress of life, there are hidden corners where danger can lurk. These dangers are often invisible to the naked eye, yet they pose significant threats to our health and well-being. HIV, the virus that attacks the body's immune system, can also find its way into the brain. This invasion is not just a physical one, it disrupts the delicate balance of the brain's ecosystem. This is a reality faced by millions of people living with HIV who must navigate the complexities of managing a chronic illness that affects multiple systems in their bodies. Even when the virus seems quiet elsewhere in the body, it can remain active in the brain, silently causing damage over time. This silent persistence makes it a formidable foe. Understanding how HIV persists in the brain is crucial to developing better treatments and one day finding a cure. Researchers are delving into the brain's microenvironment to uncover the mechanisms that allow HIV to hide and thrive. It's a journey that takes us deep into the microscopic world, where the interactions between viruses and cells are both intricate and relentless. In this microscopic battlefield, tiny viruses wage war within our very cells, hijacking cellular machinery to replicate and spread. But it's a journey we must take, driven by the hope of alleviating suffering and improving the quality of life for those affected by HIV. For the sake of those living with HIV and for the future of human health, we must continue to explore, understand, and innovate. The quest for knowledge and the drive to find solutions are what propel us forward in this scientific endeavor. Researchers around the world are working tirelessly, using cutting-edge technology and innovative approaches to unlock the mysteries of HIV in the brain. Their efforts bring hope for a future where HIV can be effectively managed and perhaps one day eradicated. This vision fuels the relentless pursuit of scientific discovery and medical advancement. It's a collective effort that involves not just scientists and doctors, but also communities, advocates, and individuals living with HIV. Together, we can make strides towards a healthier, more hopeful future. As we look towards the horizon, we are reminded that every step forward in understanding HIV in the brain brings us closer to a world where this virus no longer holds power over our lives. The brain and spinal cord make up the central nervous system, or CNS. Think of it like mission control for your entire body. The CNS controls everything from your thoughts and emotions to your movements and senses. It's a vital system, protected by a special barrier that keeps harmful substances out. But HIV is a cunning adversary. It's like a microscopic thief, able to slip past security checkpoints and infiltrate even the most secure locations. Once inside the CNS, HIV can hide from the body's defenses and the medications designed to control it. This ability to breach the brain's defenses is what makes HIV so challenging to treat. It's a reminder that even in the face of scientific progress, we are still vulnerable to the forces of nature. HIV is a master of disguise. It has evolved to be incredibly adept at evading the body's defenses, making it a formidable opponent in the fight against infectious diseases. Once HIV enters the body's cells, it performs a sneaky maneuver by inserting its genetic material into our own DNA. This integration is a critical step in the virus's life cycle, allowing it to hijack the cell's machinery. The infected cell then becomes a factory, churning out new HIV particles. These new particles go on to infect other cells, perpetuating the cycle and spreading the virus throughout the body. Antiretroviral therapy, or ART, has been a game changer for people living with HIV. This treatment regimen helps to control the virus, allowing individuals to lead healthier lives. ART works by stopping the virus from replicating. However, it's important to note that while RT is highly effective, it doesn't completely eliminate HIV from the body. The reason for this is that HIV can hide in reservoirs within the body. These reservoirs act like dormant seeds, lying in wait for the right conditions to reactivate and start producing the virus again. One of the most challenging reservoirs to deal with is the brain. HIV can cross the blood-brain barrier and take refuge in brain cells. In the brain, HIV can lie dormant, hidden from both the immune system and antiretroviral drugs. This latency makes it difficult to target and eliminate the virus completely. This means that even when someone with HIV has an undetectable viral load in their blood, the virus may still be lurking in their brain. This hidden presence poses a significant challenge for achieving a complete cure. While this is a sobering thought, it's crucial to remember that knowledge is power. Understanding the mechanisms of HIV's hiding strategies is the first step toward developing effective treatments. Researchers are tirelessly working to uncover new strategies to flush HIV out of its hiding places. By targeting these reservoirs, we can move closer to a future where HIV is no longer a threat. Scientists are exploring various approaches, such as shock-and-kill strategies, which aim to reactivate dormant HIV so that it can be targeted and destroyed by the immune system or antiretroviral drugs. Another promising avenue is gene editing technology like CRISPR, which has the potential to precisely remove HIV genetic material from infected cells. These innovative treatments offer hope for the millions of people living with HIV. With continued research and advancements, we are making strides toward a world where HIV can be effectively managed and potentially cured. It's also important to support those living with HIV, providing them with the resources and care they need to lead fulfilling lives. Community support and education play a vital role in this effort. The fight against HIV is a global effort, requiring collaboration and dedication from scientists, healthcare providers, and communities around the world. Together, we can make a difference. As we continue to learn more about HIV and develop new strategies to combat it, there is hope for a brighter future. A future where HIV is no longer a life-threatening condition, but a manageable one. Together, we can end HIV. By staying informed, supporting research, and fostering a compassionate community, we can overcome this challenge and create a healthier world for everyone. Waking the Dragon HIV Reservoirs and Reactivation. Imagine a sleeping dragon curled up in a cave. This dragon represents the HIV reservoirs that lie dormant within the brain. These reservoirs are like hidden pockets of the virus that remain inactive for long periods. As long as it slumbers, it poses no threat. The virus remains contained, unable to cause harm or spread. This is the state we aim to maintain with effective antiretroviral therapy. But if disturbed, it could awaken with a fury. This reactivation can lead to a resurgence of the virus, causing significant health issues. This is similar to how HIV reservoirs work in the brain. Even when the virus is suppressed by antiretroviral therapy, these reservoirs can reactivate, posing a continuous threat. Even when HIV is suppressed by antiretroviral therapy, these reservoirs can reactivate. This reactivation is a major challenge in the fight against HIV, as it can lead to the virus spreading once again. This means the virus starts replicating again, potentially causing damage to the brain and other organs. The reactivation can lead to neurological complications, cognitive impairments, and other severe health issues. Scientists are working tirelessly to understand what triggers this reactivation and how to prevent it. They're exploring various strategies to keep the virus dormant and prevent it from causing further harm. Studies like those by Tang and colleagues have shown that HIV can persist in the brain despite effective antiretroviral therapy. This persistence is a significant obstacle in achieving a complete cure for HIV. This research underscores the importance of addressing HIV in the brain, not just in the rest of the body. The brain is a critical area where the virus can hide and evade treatment. It's like fighting a war on multiple fronts. We need to tackle the virus in every part of the body, including the brain, to achieve a comprehensive solution. We need to target the virus wherever it hides, including in the intricate pathways of the brain. This requires a multifaceted approach, combining advanced research, innovative treatments, and continuous monitoring. Collaboration among scientists, researchers, and medical professionals is crucial in this battle. By working together, we can develop more effective strategies to combat HIV reservoirs in the brain. Prevention strategies are being developed to keep the virus dormant and prevent reactivation. These strategies include new medications, therapeutic approaches, and lifestyle modifications. Advancements in brain research are providing new insights into how HIV operates within the brain. These insights are helping to develop targeted treatments that can more effectively address the virus in this critical area. Understanding the triggers of reactivation is a key focus of current research. By identifying these triggers, scientists hope to develop interventions that can prevent the virus from waking up and causing harm. The future of HIV research holds promise, with new technologies and methodologies being explored. These advancements are paving the way for more effective treatments and ultimately a potential cure. Patient stories highlight the real-world impact of HIV reactivation. These stories underscore the importance of continued research and the need for effective treatments to improve the quality of life for those living with HIV. Community support and awareness are also vital in this fight. By raising awareness and supporting research efforts, we can make significant strides in combating HIV reservoirs in the brain. There is hope on the horizon. With continued research, collaboration, and innovation, we can find ways to keep the dragon asleep and one day eliminate HIV reservoirs entirely. Unmasking the enemy, identifying the hiding spots. To defeat an enemy, you need to know where they're hiding. Scientists have identified specific cells in the brain that act as major reservoirs for HIV. Microglia and astrocytes, cells that normally support brain health, can become infected with HIV and harbor the virus long-term. These cells are like double agents, working for the enemy without being detected. Understanding the role of these cells is crucial to developing new treatments. If we can target these cellular hiding spots, we can potentially eliminate HIV reservoirs and prevent the virus from re-emerging. It's a complex puzzle, but each piece of the puzzle we solve brings us closer to a cure.